And back in Vue, you can choose to keep that clipping plane or remove it. I'm not going to need it anymore, so I'm just going to get rid of it. And now what we want to do is set up the population to be able to move that over to the painted ecosystem. So I'm going to select the terrain, edit the material, go into the material for the ecosystem, which is currently called grass. I'm just going to rename that trees. And then turn on the variable density. Edit the function, and we're going to add in a texture map, set it to the texture map, not the projected texture, because we need the UV coordinate input, or just the ability to manipulate the texture coordinate. That's what this purple link is, the X and Y texture coordinate. So we can select the UV coordinate and switch that input from UV coordinates to camera projection. Our projected camera, our projector, is camera 3. And since we rendered it out square, we can keep the aspect ratio at 1. Now what I want to do is load in that image. And I'm going to set the interpolation type to bilinear and turn off the repeat. We want no repeating. And I'm also going to invert. So in the upper right, we can just invert the map and just connect our density to the grayscale output. So now if I do populate command, it's going to populate only within that defined area. So this is now our zone that we can work with. And I'm going to change back the camera output to Panavision. And I do need to switch to camera 1 to get the animation. And now we have an area that we can increase details, defining the density separately from the rest of the population. Now, I am going to double check and make sure that the output from the texture map is not going to affect the range that we have. What I'm going to do is set up a filter in between the link between the density and the texture map and change that over to just a map. Set it to -1 is the lower value, 1 is the upper for both input and output, and just clip the out of range values and then repopulate. And it seems to be identical, so just making sure that we're staying in that right range. And it does look like my function scale is a little off on the Z. Z really shouldn't matter in this case, but just making sure that all of those are set to 1. So now what I can do is basically select all of these instances and move them over to the global ecosystem. So I'm going to go up to the top to the ecosystem selector, select all, move instances to global ecosystem. Which is the painted ecosystem, and hopefully they show up. At the moment, it does not look like they are showing, and it looks like I just need to refresh the OpenGL. So now we just need to change the ecosystem to have a reverse function. So edit the density, go to the texture map, and what we're going to do is invert this. And now if I was to populate right now, what we're going to see is just the reverse texture map, and it's going to be cut out on the outside. The painted ecosystem is mixed with that, so if you want, what you can do is change the display options to none, if you don't want it showing, and just to be able to take a look at where the texture is. So what we need is basically an outside addition to the extent of the texture map. So we're going to go into the material and edit the function. And what I need to do is add in another texture map connecting the texture coordinates to the same as the camera projection, clearing out the texture and making sure the tiling mode is set to none. I'm going to invert, and we're going to be using the alpha output, which should give us a reverse function. And if you're using Snowflake, you can go to the meta node texture map outside clip, which is already this setup with that outside alpha incorporated into a texture map and pre-designed. I'm going to show you how you can set this up for yourself if you don't own Snowflake. Basically what we're going to do is use this other texture map as a ratio for a blender to also add a constant node. So I'm going to add a constant number 1, which is going to be equal to white. And that's what we need for the outside range. We're going to add a blender, and we're going to connect the input 1 to 1 and connect the ratio to the other texture map, the alpha output, and clip the ratio 0 to 1. So I've just gone ahead and populated that, and now you can see that that outside range is filled in, and the center point, or the defined area, is subtracted from the ecosystem. All little dots that are showing up are from the ecosystem selection. I'm going to go ahead and select none, and then that should go away. We're still going to have the other dots showing the colors for the painted part of the ecosystem, but not those selected red dots. So now what we can do is switch the ecosystem on the terrain, the material ecosystem, and there's just a little bit of an OpenGL error showing the painted ecosystem. If we switch the camera, we can see that it's gone. We can now change that material ecosystem over to dynamic population. So that's going to save scene resources when we're saving. Also, since that's pretty much going to be static, we're not going to be editing that. We don't need to worry about it being in the scene. And once we render, it's going to show exactly where we need it to. And now we can just focus on this defined area. Change the display mode so we can see it. And now we can go in and paint and customize this part of the ecosystem. So what I want to do is just make a few modifications, switch over to the eraser, erase a bit of everything, and just kind of cut out some areas just so that we can see the editing. And now if we render, what we're going to see, set that to the final settings, making sure that everything I made before for the custom render, the apply materials and all that is back on and not checked off. I'm just going to do a smaller render to screen, and we can take a look and see both the dynamically populated ecosystem along with the customized painted ecosystem. So here's the render with both the global and material ecosystems showing up. And since I do have preview dynamic population turned on, file options, preview dynamic ecosystems. After you render a frame, it'll update and show the defined value. So if I got mine set to 150,000, it'll show 150,000 instances of the dynamic population. Go ahead and increase that a little higher. And then we just have that section of the terrain being populated. So that's really going to help for memory. And since we're not going to worry about that population saving with the rest of the scene, we're also able to really cut down on file sizes. So now that we have this zone, we can go in and probably want to spend a little more time in the shot in this area so that it maybe slows down and kind of comes around the area. And then what I can do is paint in some higher detailed objects or place in some higher detailed plants rather than these very basic trees that are currently showing up, because I'm using plum trees, fir tree, and that's basically it. So those are very low quality plants, so I can go ahead and swap those out. We can also use the ecosystem selector in order to select some of the instances, and under manipulate we can change the object type to a specific object. So anything loaded into any of the populations becomes available within this manipulate. So if I wanted to load in a high-res tree to swap those out, we can go to the paint ecosystem and add in a new plant. So let's grab a tree that's higher res. Let's do the broadleaf straight trunk, click OK. And now we can either select it, paint it in, or we can go back to the selector, manipulate, and change the type to, now we can see the broadleaf straight trunk becomes available. So we can swap those out, and that way you're able to really define a level of detail more specific to the shot in whichever area is going to be the primary focus. So if we need to edit this, since it looks like the size is a little bit off, I'm going to switch this over to the perspective view, go back to frame 0, and we have this very large tree in here. The scale looks like it's quite different. So I'm going to select Paint Ecosystem, select only selected item, broadleaf straight trunk, and undo. I did have it set to eraser. What I'm going to do is choose the color and scaling. Just turn off coloring, choose scaling, turn it down, and now we can scale down these objects. So they're not huge. Or we can color them as well. And if we want this shot to come in a little closer to any of these areas, we can use the camera projection to define a more detailed material, whether or not you want to paint something on, project it, or setting up ground vegetation, grass, any smaller plants that you're not going to need throughout the entire scene, you just want to have in these specific areas. And don't feel limited to just using one projection if you're using this. Of course, you can define any of the areas that you need to define. So if we want to set up something in the front, this part of the terrain, we could do the exact same thing we just did. All we would need to do to combine the populations. So you would originally render out the first mask by itself, populate it, send it over to the global ecosystem, which is the painted ecosystem. But once we get to this point where we need to subtract that mask, we also need to basically copy this over. So this entire function, whether or not you want to create a meta node out of that, save it out for later use, and just make some of these options available. If we had a different camera, then we would just change the projector type, and what we can do is use a blender and set the mode to take the new mask. And what we can do is just subtract from the other part of the density. So any additional maps you can subtract, but you do need to make sure that you have a lot of that outside alpha set up. Otherwise, it's going to create a lot of boxes throughout the terrain. You could also set up one universal map if you wanted to. So rather than defining all these specific zones, unless you're going to be really taking advantage of the camera projection and having additional mats projected onto the terrain, you could just set up one camera looking down if you wanted to use camera projection, or render out the entire terrain and paint in the areas you want to have defined and just set it up with one texture map. So that's one little way to do that. And I did do another training for Vue 7, and all of these techniques will work for Vue 7 as well. So if you're using Vue 7, not Vue 8, or you need to fall back to a previous version for any reason, which is sometimes likely, considering some of the issues. The training I did was optimization dynamic population, where you can use objects to define these types of zones. So rather than using camera projection, you could set up a sphere and use that to subtract an area or populate within an area or preview the dynamic ecosystem that way. I also want to note that in this case I have everything pretty much controlled by slope of the terrain. So if you already have a variable density set up as a function, let's say you have a noise node controlling the density, but you still want to use this technique, all you would need to do is take the current density control, let's say it's a noise node, or whatever function, just take the last link that's numeric output, add in blender node, or you can use a combiner node, depending on how many different maps you have set up. Take the original population to input 0 of the blender, and input 1 for that texture map. And not setting it to blend, what you can do is subtract. But the only problem with using subtract is it is also going to subtract all of the data. So if you need to multiply, might work best. Minimum as well. Max will take that white alpha overlay and block out the entire function that you currently have. So minimum, multiply, or subtract. You might just have to play around with it, see if it's going to work best. Minimum, it should be a good solution. Turn off dynamic pop and just populate this just to take a look and see how that works. It looks like the minimum mode is working. So what we have is now a noise node controlling the overall density, where we can see there are a lot of patches now that have less population. And then we still have the subtracted area for the painted ecosystem gone. So if we go to the painted ecosystem and just change the display options to none so that it's not showing, we'll be able to see that that is still separate and we don't have any trees being created within that area. And I just want to make one last note, and that has to do with using camera projection in this way. And really, at any time you use camera projection, you need to make sure that you don't touch the camera that is projecting once the render has been set and you've got it defined what you need. So in this case, we have camera 3 as our projection, and to avoid any sort of movement on this camera, there are ways to lock it in place. Now, some of the options, there are a couple of ways you can forbid animation. There's a couple of different options. For the most part, go here and switch to the camera. Changing some of these options might reset the way the camera works or change the position. So the best thing to do is take the position vector and the orientation vector. And if you have any sort of pivot offset, keep that recorded as well. So what we can do is first I'm going to, just in my text editor, I've got that open on a different window, so you can't really see it right now. I'm just going to go ahead and copy and paste all of these values to be able to really quickly add them in to a graph in order to lock this camera in place and not worry about moving it at all, because it will completely destroy any functionality or the ability to manipulate or move the camera within the scene, and it'll be entirely controlled by the graph. So to set this up, got all my values recorded, and what we need to do is create two constant vectors. I'm going to use a connectable constant vector, and that way I can leave it open if I do end up wanting to change it. Actually, now that I think of it, there was an issue with the connectable constant vectors not actually applying the right information, so I will use just a constant vector. We're going to be using these to lock them in place. If we want to change it, we can do it with this node. We don't need to worry about connecting it elsewhere. So I'm going to add in another constant, and because I had the previous constant selected, it might create sort of an internal duplicate. It's been a problem in the past, so after I create this duplicate, I'm going to change it over to a different type of constant and then switch it back to a constant vector, which will clear and create the default. And we're going to set one for position and one for the orientation. And you really want to make sure that these values are entered before you connect them to the final outputs. But what I can do is just take all of the XYZ values from the orientation. Like I said, I already copied and pasted them into a text editor just to make it a little quicker. Or you can just copy and paste directly from the orientation. Since the camera is still selected, we can still use the numeric output to record these values and copy and paste directly into the graph. So that option is also available. Orientation, these vectors will pretty much remain the same regardless of the internal unit. Position and scale will change depending on the internal unit of the scene. So if you go to File and Options, Units and Coordinates, my internal unit is set to 1. So in this case, all I need to do is record those direct values for meter. Since it's 1 meter, and the value I had copied over is in meters, I can just copy and paste the data over. But if the internal unit was, say, 0.1 meters, I would need to bump the decimal point over by 1, and do that for every single unit or every single part of the vector. In future versions of Vue, in the next update, which is currently already available as a beta to the public, what you can do is change a lot of the inputs to control a specific value being based on the units in the scene. But in this case, because we have a constant that's not based on an input, we really can't define that, so we still need to pay attention to that internal unit. So once the position and orientation are set, first thing I'm going to do let's create a duplicate of the camera. So I'm going to store camera 3, and that way, in case something does happen, we don't lose that information. You also want to lock the focal in place, and the focal is currently set to 70. So we need to add in another constant, which is going to be a number. This number output is actually set up for field of view and not based on focal length. So it does need to be manipulated. And in other words, it needs to be divided by 2. So if we have 70 millimeters, we need 35 to be that number to connect to the focal to get it to return as 70 millimeters. If you're using Snowflake, the metanode collection version 2.0, you can load in the metanode focal length, which automatically sets up that division. If you want to create your own node, you can add in, what works pretty well is just taking a blender, setting it to divide, adding in another constant number of 2, and then just taking input 0. Go ahead and zoom in here so you can see it a little bit better. So starting input 0 on that number, input 1 on the 2, and then this is going to return the correct number. So you could just type in 70 in this case. And then it's automatically divided in half, and we're going to get the right output. Connect the focal, it'll update the focal automatically. So if I did change this, let's say 50, we'll see that it does change to 50 in the camera numerics up here in the aspect tab. So now that everything's set, we can just connect the position and the orientation to these constants and click OK. The camera is now locked into position. Won't be able to move it. One problem that was with the connectable constants is that you could still sometimes move the camera around, and then it would reset things. So using the non-connectable constants might work the best. So now if I try to move the camera with the control center, it's not going to let me. Can't rotate, can't move, so it is locked into place. Very good idea to do that before you render. So if you're going to be doing this, you might want to render or lock the camera first before you render. If you end up changing it, then you can update that. But that way it keeps it in place, because the decimal point values are only going to go so far. So there might be a slight offset the way I just did this, because I rendered first and now locked the camera. So depending on how far the decimal points go within the output, because I'm just copying from the numerics tab, which only shows so far, and the rest of the values are being cut off. So even if it is different, it's not going to be available. So one thing to keep in mind.